Alright guys, today we are doing trigonomic identities, and in specific we're going to be verifying identities. So I'm going to make this as easy as possible. And one thing I do know is that it's not an easy concept to learn, so I apologize ahead of time if it's confusing, but I have an example that I wrote down that I really think is good because it shows like a general example of what you're probably going to see on a test, and it's not over complex. So firstly, when we're doing these problems, is you want to take into consideration that you're going to be using a lot of algebra, and you're going to need to know your identities. You're going to need to have them memorized. Whatever ones your teachers tell you that you should know, you're going to have to know for the test. That's the way they work. So it's not as horrible as it sounds. I mean, just doing practice, you'll be able to pick up on them easily. It probably takes you just 2 hours worth of studying to get this concept down 100%. I know it sounds horrible, but fun fact, in high school, I got the worst grade I ever got on a trig identity test. I got a 4 out of 50 on a trig identity test. And in college, after a couple hours of studying, I got an 100% on a much harder trig identity test. So it really is just the effort you put into it. So yeah, I'm going to try to show you guys this example, and I'm going to try to dumb it down as much as possible because nobody ever did that for me, and that's where the problems came in. So we're going to start out, just these verifying problems are actually kind of nice because you know the answer, and by that I mean like we know that we have to find 4 secant x. That's what we're looking for. The only thing you're graded on with these is just the algebra it takes you to get to that point. So with this one, with any of these problems, you're always going to want to start with the most complex side. So in this one, you're going to be focusing only on this left-hand side, and we're just going to be doing simple algebra and using a couple identities just to get to the 4 secant x that we're looking for. So the first thing we're going to do in algebra, I mean, when you see that there's a 4 on both of these, we're going to want to pull that 4 out. If a 4 is on each number in the side of the problem, we're going to pull that out. So we're going to isolate 4, and we're left with 4 cosine x plus sine x tangent of x. What I like to do is I like to get as much of the fine details out of the way as I can. So I take the 4 out, and then what I would do next is I would break up this tangent, because tangent's sine over cosine, so you might as well just expose that at the beginning, So we're going to keep the 4 out, 4 cosine x plus sine of x, and then remember tangent sine of x over cosine of x. So it's still the same thing, it's just we're rewriting it differently. Let's bring cosine over 1. So 4 cosine of x over 1 plus, and let's multiply these sine x's right here. You see we can do that. It's just practice, guys. I mean, once you start to see these things, because you really don't. I mean, this sine of x is over 1 if that makes it easier for you. So we're just multiplying these together. So we're going to get sine squared of x and the 1 and cosine multiply together. So this is over cosine of x. So in recap, all we did so far is we pulled the 4 out, and we separated tangent. We showed tangent was sine of x over cosine of x, and from there we multiplied the sine of x and sine of x together to give us sine squared of x. So now, believe it or not, we are most of the way done with this problem. I mean, these are really simple. It's just algebra is the key component to it. So from here, what we're going to want to do is we're going to want to get cosine of x on both sides. We're going to want a common denominator so we can add these together, right? So we're going to multiply this cosine of x over here on both sides, or on both levels. So we get cosine square root of x over cosine of x, because we just multiplied that, plus sine square root of x over cosine of x. So now we have a common denominator. let me actually rewrite this. I'm going to rewrite this so that only cosine is on the bottom for both terms here. Plus, and then cosine of x. So this is where we're at right now. We have cosine square root of x plus sine square root of x over cosine of x. Now, one thing that you guys should know, and you guys will learn it from your identities, is cosine square root of x plus sine square root of x is actually equal to 1. That's a trig identity. That's a very common one, so you should definitely know it. So all a trig identity is that's just going to substitute out for the 1, and it's still over cosine of x. And 1 of cosine of x, if you guys don't know that, that's secant of x. So look what we're left with. We have 4, this is the same thing as 4, is equal to, is multiplied by secant of x, and that is equal to 4 secant of x, which is our answer. So that is how you verify an identity. I tried breaking it down as much as I can and explaining as in detail as I can, because I know what it's like to be completely clueless on this subject, and it is very difficult to get a grasp of it. So I hope that helped. I'm going to be doing a trigonometry, calculus, chemistry curriculum under this YouTube channel. So if you guys wanted to subscribe or like this video, you guys can come back to my channel in the future, and I should in the near future have a pretty fundamental high school and college curriculum for all of those courses. So if you guys missed class or something, you can come check out the videos and get filled in on what you missed. Alrighty guys,